So we're going to essentially talk more about trig and inverse trig is essentially what we're going to be covering. So inverse trig, arc cosine, arc sine, these types of properties is what we're going to be speaking about today. So let's remember what we were previously doing, just since it's been a little bit. So we were looking at the arc cosine, and we were restricting our graph because the whole cosine graph goes up to 1 and goes to -1 here. Now we had a restriction on the domain for the cosine graph between 0 and pi, because then this way we can say it is a one-to-one function, and therefore we can find the inverse. Otherwise, it would not be one-to-one if it was on the entire domain. So this is why we make that restriction. So we're supposing, we're defining this t between -1 and 1, and we're letting the arc cosine of t, denoted arc cosine, to equal the inverse, so cos inverse t. And this is the angle in 0 to pi, whose cosine equals t. So this is where we left off. So just to recall from what we did a few weeks ago, remember that the domain of the inverse is the range of the original function, is what I was writing down. And also then remember that the range of the inverse of the domain of the original function. So the range is the domain of the original function. So remember these things. So this is essentially where we left off on this slide. I think I wrote this part down, this last part. If anyone wrote it down, I'll just give you a second. Okay, so we're going to evaluate the following arc cosine values. We're going to evaluate the cosine inverse of the 0. So this is by definition, I'm just writing the same thing. It's the same thing as arc cos of 0. So what does this equal? So I'm going to write it over here. We're looking for the cosine of what number between 0 and pi is equal to 0. So this is what we're looking for. So if we go back to our graph, what number between 0 and pi is equal to this 0? Anyone from reading the graph? Yeah, pi over 2. So it's just pi over 2. Okay, let's do the next one. What about the inverse, the cos inverse or arc cos? Same thing, tomato, tomato. So cosine, so of what number is between 0 and pi and is equal to 1? So we'll go back to the graph. What number is equal to 1 of the cosine graph? 0, right there, yeah. So it's just 0. And then -1. Oops. Right. It'd just be pi. Okay, good. Just give me a second. Okay, so we need to pay special attention to the notation. The next three examples look very similar. They're actually different. So this is arc cos of 0.5 versus this one is just going to be 1 divided by, because it's all raised to the exponent -1. So it's cos of a 0.5. And this one means something different too. This means cos, sorry, of 1 divided by 0.5, which is also equal to cos of 2. So as you see, like these are not equal to each other. This is not equal to this. These are not equal, and these are not equal. So they're not all one and the same. They are different because you have to look at the exponent. Here, this -1 is between the cos and the angle, so it is the inverse. Here, it's everything in brackets to the exponent -1. And here, the -1 is the exponent of the angle, or whatever in the brackets. So they are different. Common mistake. So sketch the radius of the unit circle corresponding to the angle theta, which is equal to cos inverse square root of 2 divided by 2. Let me just write it down. So the cos of this is equal to arc cos of square root of 2 divided by 2. Now, what is this going to be equal to? So we could say because, well, we could first try to sketch this on the unit circle. So I'll make a note. So because the cos of an angle equals, what angle equals square root of 2 divided by 2, and is between 0 is less than this angle is less than pi, because that is the domain. Do we know what angle this is? Yes, right, 45 degrees. So that is pi divided by 4. So this is pi divided by 4. So now I'm just filling it in. So that is, would be sketching the radius of this unit circle corresponding to this particular angle. So let's see an application problem. Suppose we have an 11-foot ladder is leaned against a building. So let's draw this out. We have, oops. And we have like a ladder here. And it's leaning against the building. So ladders have steps. Okay. So we have an 11-foot ladder leaning against the building, reaching to the top of a second floor window. So there's a window up here. 9 feet above the ground. So this is 9 feet above the ground. What angle does the ladder make with the building? So what is this angle here? And it's the buildings are perpendicular, of course, to the ground. So this would be 90 degrees. Okay, so are we going to, I always like to write SOHCAHTOA at the top when I do these types of problems, personally speaking. So which trig angle or trig identity would we be using to solve this problem? Sorry? Cosine, right, it's cos. So I hope, does everyone see that? Right, okay, so cos. So it's going to be adjacent divided by a hypotenuse. So adjacent is 9 divided by 11. All right, SOHCAHTOA up here. So adjacent is A divided by H. This means our cos. So we have to solve for this. So basically we want to find this angle, theta, where it's between 0 to pi, and this is 180, such that cos of this angle is equal to 9/11. So we just would want to solve for this. So how do we solve this? We can take basically the inverse. So we notice it is in the domain. It is between 0 and pi. So it checks out that box. So we just take, to find the angle, we can take the arc cos of 9/11. So then we could use a calculator. If it was on a test, we stop at this point, right? Because we're not using a calculator, but if we were doing it on an assignment and we could use a calculator, so using a calculator, what do we get? What is this value? So what is the value? Punching it into your calculator. Yep, 35. Did everyone get 35? So that it's 35 degrees. So this means this angle is approximately 35 degrees. So the same, yes? Here? No, I'll tell the grader to give you the marks for that. But I think you should actually do it. to be really honest. I think you should use the calculator because if you take physics or any other course, they'll expect you to use a calculator. So this is pre-calculus to prepare you for other courses, and other courses they'll expect you to use the calculator. No, because it's going to be simple enough for you. Don't need a calculator, but on the assignment you can use a calculator. Just, I know it's a little confusing, but
For our some coming up, so we just follow on to the article side.
yeah, on the, and the same with on the assignment and on the test. You can stop there, but I would try to do it by hand first, like without a calculator, and then I would go back and check it with a calculator, and then put in that final answer. But I'll try to tell the TA not to ding you with marks or anything. And just because I'm thinking about what's going on the next step, the next after this course for you. But it's not a big deal to punch it in the calculator, right? So we defined the arc sine as basically similar to what we just did with the arc cosine. So once you know one approach, the approach is kind of the same for, or similar to the others. So let's now look at the arc sine. So let's draw it. It's not easy to draw a straight line with this. So imagine okay. So we're going to consider the sine function on the domain from negative pi divided by 2 to pi divided by 2. This is our 0, like we've drawn before. So I stopped it between negative pi divided by 2 and pi divided by 2. Because as you can see, if you draw horizontal lines, it satisfies that test, therefore, the horizontal line test, therefore this function is one-to-one on this specific domain from negative pi divided by 2 to pi divided by 2. So therefore, on this specific domain, we can define the inverse. On the entire domain, we cannot define the inverse, just on this specific domain. So if we suppose a t goes from -1 to 1, the arc sine of t, denoted by arc sine of t, is equal to sine inverse t, and it's just the angle in between a negative pi divided by 2 to pi divided by 2, whose sine equals t. So we can evaluate these following. So the first one's kind of straightforward. So it's the arc sine of 0 is equal to, anyone? 0, right, 0. Because if we go back, it's just going to be 0. And the next one. So, and I'll just make a little note. So the sine of what number between negative pi, so how we think of this is we're looking for the sine of what number between negative pi divided by 2 and pi divided by 2 is equal to 0. So for the next one, we're looking at the sign of what number between negative pi divided by 2 and pi divided by 2 is equal to 1. So where is it equal to 1? Right, pi over 2. Perfect. And then the last one, arc sine of negative 1 would be, right, negative pi over 2. Perfect. Okay, so we're going to sketch the radius of the unit circle corresponding to theta is equal to sine inverse a half. Let me draw a circle. Imagine it's a perfect circle. It's not. So the sine inverse of a half, we know that this is equal, just same thing, arc sine by definition. I'm just writing it. What number is equal? So what number between negative pi divided by 2 and pi divided by 2 is equal to a half? So there's some sheets. So this would be 1. So you could look up from a few lectures, like a lecture or two ago, there was a chart and it's going to be on your quiz number 6. I'm going to give you the chart for our quiz number 10. And for your final exam, I'm going to give you this chart. And I also posted it online. But you could try to find where it is a half. Where is this equal to? So it's going to be opposite. So this is our angle. Opposite will be a half. You can figure out that this is going to be 3 divided by 2. So opposite over adjacent. So what angle is that? Anyone? Yeah, like, so in terms of pies, it's pi divided by 6. You see it? Okay. So I'll just make a little note. So this is because sine of pi divided by 6 is equal to a half. And it's also because pi divided by 6 is between negative pi over 2 and pi divided by 2. So we're okay. So the answer is pi divided by 6. Did you say it was 30 degrees? Yeah. So it is, and remember, yeah, pi divided by 6 is 30 degrees. What's important is that there's many values. There's infinitely many values. It goes around and around in a circle, right? But we only want where it's between negative pi divided by 2 and pi divided by 2, like this part. So this is specifically our angle, because there's infinite, we could keep adding like plus 2 pi, plus 2 pi, 2 pi's to this. But this is only defined in this, the inverse is only defined in this domain. So here's a word problem. Maybe this is more interesting. So let's all solve this. Again, the first thing we do, we read it, and we draw like a little sketch. So let me try to draw. So we're in a car driving 4 kilometers. On a straight road. But as we go along the road, our altitude goes up by 300 meters. So it increases 300 meters. As we're driving along this road. So this is what it means. What is the angle and elevation of the road? So we're in our little car. This is a person here. Okay. So we're driving along the road. So 4 kilometer road. If we convert that to meters, if we wish, because the units here, this is 300 meters. This is kilometers. We would have to convert it. So this would be 4,000 meters. This is in 90 degrees. This is in meters. And this is our angle that we're looking for. Some exhaust. Okay. So first is like setting up the word problem and reading it kind of carefully and drawing a diagram. So are we going to use, so I would write, of course, SOHCAHTOA here. This is how I do it. So which one are we going to use? Yes. Right, sine. Perfect. So sine. So opposite. Over hypotenuse. So then this implies, of course, the sine is equal opposite 300 divided by 4,000, which is just 3/40. So then all we do, so we want then therefore to find the angle theta, whose sine is 3/40. So of course, this is, you need a calculator, or you could just write it out like so. We want to find sine inverse or arc sine of 3/40. So, and this is approximately equal to, if you punch it into your calculator, anyone? Yeah, like 4.3 degrees. So this means then the elevation, so this angle of elevation is approximately this. .3 degrees. Okay. So a good picture is actually sets you up for success. And next one, an isosceles triangle has basically two sides. Sorry, there's a typo here. Let me correct it. Of length 6 and a base of length 10. So you kind of have to know what this is first. Find the angle opposite to the side of length 10. So let's first draw a picture of this. So it has basically two sides of length 6. So 1, 2. So you would have to know that, like, in this case, it would meet kind of like halfway in the middle of the base, like the way I'm drawing it, because they're both the same side, or they both have the same length, which is 6, and the base here is 10. So that's the first step. So they meet halfway of the triangle, essentially, the two equal sides. Okay, so then we could kind of cut this in half. So then this would be 5. Let me change colors. And this would be also 5. And we create like two triangles here of both 90 degrees. So this angle is our theta. So these little angles in the triangle would be, therefore, let me change the color. Theta divided by 2 and theta divided by 2. So let me redraw it. Triangle. So we have 6, 5. This is theta divided by 2. I'm just drawing, let me make a little note. So we draw the perpendicular line from the top corner onto the base here. So that's what I just drew. So there are two equal triangles. It's not drawn perfectly. Okay, so we want to find like this theta. So we can see then, therefore, so we see that. So are we going to use, which trig are we going to use again? Sine again. So we can see that sine is just theta divided by 2, which is equal to 5 opposite divided by 6. Let me just write it down. So then we just calculate this, right? Almost. So essentially, the arc sine of 5 divided by 6 is equal, we have to use a calculator here. Anyone? Calculator. Approximately equal to, like, let's say 56.44 degrees. But that is just, so essentially theta divided by 2 is equal to 56.44 degrees. Therefore, this implies theta is going to equal to 2 times 56.44 degrees, which is equal to 112.88 degrees. So now we can define arctangent. If we remember what tangent looks like, we could draw like a little sketch to the side. So it's something like this. So let me just refresh you by like drawing a little quick picture. So this is the tan of theta. But again, we have this problem because it's not 1-to-1, right? So what do? We're going to have to restrict that domain. Okay, so we kind of cut it off at certain points, and then it would be 1-to-1. So let's draw it again. So this these vertical sort of asymptotes go from negative pi divided by 2 to pi divided by 2. So we're going to obviously restrict it to like just this part, right? Not the rest. So block out kind of like the rest. So this restricted tan function passes the horizontal line test. And if we remember what the horizontal line test is if we draw these horizontal lines, they only intersect these graphs once. So it is 1-to-1. And therefore it has an inverse. So if we, and I'll just make a little note here. So that is the restricted domain. So tan of theta is on the restricted domain. Which is, of course, negative pi divided by 2 to pi divided by 2. But it has a range. From, and because it goes from negative infinity all the way to positive infinity, which is basically the real numbers. So we can kind of see that clearly from just drawing the graph. So this is what we're saying here essentially. Suppose t is any real number. So the arctangent of t denoted by arctan of t or tan inverse t is the angle in negative pi divided by 2 to pi divided by 2 whose tan equals t. So let's evaluate the following arctangent values. So the arctan or inverse, this one is obviously going to be equal to 0. And I'll make a little note because we're looking for the tan of which number in negative pi divided by 2 to pi divided by 2 is 0. So that's how you think of it. The next one is arc tan of 1. What do we think that is? So let me sort of separate this out. So tan of which number is equal to 1? So we know that tan is sine over cos. And it also has to be between negative pi divided by 2 is less than a number is less than pi divided by 2. So a number where they're both equal in the chart. Anyone? Yes? Yep, pi over 4. Right. So it's pi divided by 4. Pi divided by 4. Pi divided by 4. Pi divided by 4. So the sine of pi divided by 4 is square root of 2 divided by 2 divided by square root of 2 divided by 2. And this is equal to 1. So then you can see this. So the answer is pi divided by 4. What about the arc tan of square root of 3? So we can use that same idea. We're trying to find tan of which number in this domain is equal to square root of 3. So we know that tan of a particular number, so tan is going to be sine over cos of some number. And once it cancels, it's going to be the square root of 3. So I'll let you know it's pi divided by 3 is the answer. So pi divided by 3. And you'll see it in a second. So the sine of pi divided by 3 is square root of 3 divided by 2. Cos of pi divided by 3 is 1 over 2. These cancel and you get pi divided by 3. And pi divided by 3 is also, which is important, between our pi divided by 2 and greater than negative pi divided by 2. Draw some lines. Okay, so sketch the unit. So sketch the radius of the unit circle corresponding to this angle. So we remember, so let me start writing in it for you. So tan inverse of 1 divided by square root of 3, this is just the arc, tan 1 divided by square root of 3. So we can remember from the table of values. That sine of pi divided by 6 is equal to 1/2. And essentially cos of pi divided by 6 is equal to square root of 3 divided by 2. So this tan pi divided by 6 is going to be equal to sine of pi divided by 6 over cos of pi divided by 6, which is equal to, this is 1/2. This is the square root of 3 divided by 2, which is equal to 1 over square root of 3. So this means this pi divided by 6 is less than or equal to pi divided by 2. So it satisfies this. Bounds. It's in the domain. So this tan inverse of is equal to pi divided by 6. So this implies the angle is equal to pi divided by 6. So we could then sketch this. I'll just draw a little circle. So it's the same question, kind of what we just did, but this one is right here, pi divided by 6. Of course, rotating this way. Of our circle. one more thing. So this is just a summary of what we just did. So here's the domains and here's the ranges. So you can see that the domains for the cosine, sine, and tan of the inverse of these and the ranges.